All right, so we're going to talk about class variables a little bit, but first let's review the other two types of variables we've seen as well as their scope. And remember, when we talk about scope, we're talking about the portion of the program when we can use that variable. So far we've seen two different types of variables. We've seen local variables and we've seen parameter variables. Now, local variables are what we started working with at the beginning of class, way back at the beginning of the semester, when we would just say something like int x gets 4, and we would declare a variable and then proceed to use it in the rest of our program. When we learned to write methods, we also introduced parameter variables, which are the mechanism by which we can input values into functions for some sort of computations. More technically, we say we pass the values to the method via the parameter variables. So in this case, local variables were valid or usable from the point they were declared until the end of the enclosing scope, and this has almost always been the end of the method. We'll refine this concept a bit later, but for right now you can think of this as the end of the method. Parameter variables we can recognize because they're part of the method header, and then they're valid or they're usable for the entire method. Today we're going to add a third type of variable to our understanding, and we're going to talk about class variables. And these are variables that are declared outside of any method, so they are not part of a specific method, and they're valid or usable for the entire program, all the methods. That's the difference here in class variables. So let's look at a piece of code, and then we'll see how a class variable can be added to this and how it can be modified from any method. So let's go ahead here and take a look at some code. And over here we have a class named ClassVarDemo, short for class variable demo. You can download this code from the class website and follow along with it if you want. But note here we have two methods. We have the function1 method that's up here on lines 2 to 9, and we have the main method on lines 11 through 25. So we start out by looking at the different parameter variables and the local variables. We notice that in the main method we have one parameter variable, args, and then we look at local variables and we see we have a local variable c, a local variable b, and a local variable q that are defined here on lines 13, 14, and 17 respectively. Up in function 1, we see that we have two parameter variables, c and d, and we also have a local variable here, int v. So if we were drawing a graphical representation of this, let's go ahead and do that. Now we talk about the different methods as having a disjoint scope. So we can graphically represent this as the two methods having two disjoint scopes. So we'll let this be main and we'll let this be function 1. And so there are no variables in our current program that exist in both methods. Okay, function 1 has the parameter variables c and d, and then it has the local variable v. Main has the parameter variable args, and then it has local variables c, b, and q. Okay, now even though we have two variables named c, we have one in function 1 and one in main, those variables do not interact based on the name. The name is irrelevant. Even though they're named the same thing, each method has its own copy and its own version of C. So, back in our code here, when we change the variable C here on line 6, we know that that in no way affects the variable C that's here in main, because the name is irrelevant here. The one thing I want you to see about this code here is let's go ahead and illustrate this concept of disjoint scopes. So when we go ahead and when we try to print out the variable v here in main, and note that there are no variables named v currently in main. We have c, b, and q for our local variables, and we have args as our parameter variable. Well, we do not have the local variable v. Function 1 has a local variable v, but that's not going to interact. So over here on our terminal, let's go ahead and try to compile our code. Whoops, I need to save my code first. Then let's go ahead and try to compile. And after I've uncommented that line, I get an error that looks like this, where it says error, cannot find symbol, and it points to the variable v, and it says I couldn't find the symbol variable v. So here on line 24, it's basically saying you used this variable and I don't know what it is. So again, this demonstrates the concept that even though we've invoked function 1 up here, and even though this function has executed, once function 1 ends, that variable v is no longer in scope and we can't use it. Now, the concept of class variables, however, is kind of an all-encompassing container here. So the idea behind class variables is that we can declare a variable outside of any method, and then we have that variable available to use for use by all methods in our class. All right. So again, the class variables are going to be declared outside of any method, so they're really easy to recognize. So the syntax here will look something like this. We'll have some syntax, and outside of any method, we'll start out with public static, and then from that point on, it looks identical to any other variable declaration. You'll start out with something like int x or int v, whatever your variable name is here. And we can have other data types here. We can have doubles, we can have strings, we can have booleans, etc. And then we assign it some value. Right? So that's the syntax. It looks very similar to the other ones we've seen, but it's outside of any method. So let's go ahead and add some of that to our code over here. So by convention, you define your class variables at the top of your file. So you note here I'm not in any method, I'm outside of any methods, and I just start out by saying public static, and then in this case let's go ahead and declare int v, and I'm going to go ahead and assign it a value, say, of -3. Okay? So let's go ahead and compile. Notice here that I still am printing out the value of v here on line 25. All right? And that used to cause an error. But let's go ahead and see what happens after we have added that class variable. Now you can see it compiles with no problems. So what's going on here graphically is that we've added a class variable v here, which is now available to all methods. So in main, when I reference the variable v, really main is in fact referencing this class variable. Now, if I were to run this code, let's go ahead and run it here. I have a couple of print statements here, one showing the fact that C and B do not change in spite of the fact that they were used for as parameter values, and then another one demonstrating the value of V. So we can see over here that I've printed out -3 from this print statement on line 25. Now, what you may be saying is, okay, Professor Summit, you have a class variable v up here, but now you also have a local variable v here on line 8 in function 1. How does that work? Doesn't that mean we have two variables with the same name in the same scope? And what does Java do in this case? And that's a really good observation. This is something called shadowing, and we'll talk about that in a future lecture. But for right now, just realize that this class variable, when they're declared outside of any method like this, those variables are available from any method, and any method can modify those variables.